Hey guys, it's time to explore IGPs, specifically EIGRP, in the deployment on this DMVPN tunnel that we have configured. Now, we're using EIGRP 1000 in the underlying IGP that's allowing us to communicate across R3. What we're going to do is we're going to play around with EIGRP 100, AS100, for the rest of our conversation, and we're going to use that to show that there's not necessarily, no, I do want to do EIGRP. It's the easiest to talk about with regard to some of the modifications and enhancements that we need to deal with. I know I initially wrote down OSPF, but promise, we'll get to that. So what we're going to do is we're going to entertain phase 1. We're going to run EIGRP on top of it. Then we're going to run OSPF on top of it, and then we're going to talk about the necessary configuration to create a phase 2 DMVPN. So we've got lots to talk about still, and we may as well just dive in. Now, what we see here is the fact that on our configuration, we have these tunnel interfaces. We have tunnel 0 here, we have tunnel 0 here, and we have tunnel 0 in each of these locations. Tunnel 0, tunnel 0. Now, what I want to do is I want to run EIGRP Autonomous System 100 across these these DMVPN phase 1 links. Now, to do that, all I'm going to do is I'm going to come over here to R2 and enable it on the hub first. So let's look at this. Router, EIGRP. I'm just going to use classic EIGRP for the purposes of these conversations. In the EIGRP videos, we went through named mode, wide metrics, and everything to the nth degree. Right now, we're not focusing on EIGRP. We're looking at what DMVPNs possibly can do to our routing protocols. So if I want to do this, I'm going to say no auto summary, which it's on by default now. Auto summary is off by default. I'm just, like I said, bad habits. They're not bad habits. They help me pass the CCIE RNS exam. But you never know what Cisco is going to do to us. And what I'm going to do is I'm going to say network 183.123.2.0.0.0.0. Now, do show IP EIGRP 100 is going to tell me EIGRP interfaces. Oh. Show IP EIGRP 100 interfaces. Notice I'm running it on serial 20. Now, is that what I wanted to do? No, I want to run it on the tunnel. So config T, let's go back up to the process here. And what I want to do is I'm going to actually remove this command. And I want to say network 10.10.10.2. That's the interface that I want to participate in EIGRP. Do show IP EIGRP 100 interfaces, and now we see it's running on the tunnel. Now, the reason I'm doing that is it's very, very easy to lose track of where you are in your config. So you're hopping around from device to device, and remember, we don't have pretty little tabs in the CCIE routing and switching exam like what I have. We have individual PuTTY sessions. I'm even using CRT, which I guess adds insult to injury. But the main thing I want to focus on here is keep in mind what it is you're trying to accomplish. We want to run EIGRP 100. We want the tunnel interfaces to participate in that routing protocol, and I'm also going to advertise my loopback. So let's go ahead and do that. I'm just going to leave myself on the camera. So I want to advertise 2.2.2.0.0.0.0, and that one should now be participating in EIGRP along with the tunnel interface. Now, what I'm going to do is I'm going to go over to R4, 5, and 6 and do the matching configuration. So actually, do show run section router, and I'm just going to grab this right here. It's not going to give me much of an efficiency. So 4. I was just going to copy and paste, but it's not going to do much for me. Router, EIGRP 100, no auto. Network 10.10.10.4.0.0, and network 4.4.4.4. Match it exactly. Go over to 5, do the same thing. Config T, router, EIGRP 100, no auto. Network 10.10.10.5, match exactly. Network 5.5.5.5, match exactly. Do show IP EIGRP 100 interfaces. Now we see that we're running the 2 interfaces that we need. but we still haven't seen a neighbor relationship come up, and that's going to attest to one of the problems with these dynamic tunnels. So router EIGRP 100, no auto, network 10, 10, 10, 6, match exactly, and network 6.6.6, match exactly. All right, I'm going to go ahead and take myself out of the equation. All right, now let's take a look at this. Let's go to the hub. Since the hub is interconnected to every device, and let's see what's going on. Show IP EIGRP neighbors. Let's see what we got going on here. Well, here we have serial 20 under 1000, which we know about. But notice here I have a tunnel interface, tunnel interface, tunnel interface. But right here, the problem is I have a queue count greater than 0. Now what's happening here is we're trying to initiate this connection, but what's happening is our multicast traffic that allows us to pin up our configuration in EIGRP is falling apart. Why is it falling apart? It's falling apart because it's missing. We don't have those configurations. Show run interface tunnel 0. Notice I have nothing in here talking about multicast traffic. And multicast traffic must be mapped. A better example would be on R4. Do show run interface tunnel 0. Another, or a better example would be this idea of the fact that we have this mapping. Well, just like we map IPv4 traffic, it's also, or unicast traffic, it's going to be important for us to map multicast traffic. Now the problem is we need to configure the next hop server such that it can learn these addresses. Now the way we're going to do that is we're going to use a special mapping that's going to allow us to dynamically learn them. We don't have to. We can actually do them static. I'll end up doing both just so that you can see the process. So up here on R3, or on R2, excuse me, all I'm going to do is I'm going to come under here and say interface tunnel 0. And I'm going to say IP NHRP map, and one of my options is multicast. So what I'm going to do is I'm going to say map multicast, and my other option here is to say dynamic. Now I could have just as easily put these in here as regular NBMA addresses, but we'll look at this. Now, is this going to make a change? Do show IP EIGRP neighbors. Notice my queue counts are still greater than 0. That's always bad. And if I come up here and I say do show topology table, show EIGRP IP, show IP EIGRP topology table, those are our connections for 100. Down here is, here's 100 down here. The problem is they just keep bouncing. Up, down, up, down. Well, what we'll do is let's fix that. Let's go over to R5 and see if we can't stabilize this scenario. Interface tunnel 0. What I'm going to do now is IP NHRP map multicast, and notice I need to specify either dynamic, which isn't really going to help me here, but I can do a static mapping for multicast. Notice it's to the NBMA address. So that's going to be to that public address, the one that's reachable. So that's going to be 183.10 or 183.1.23.2. We'll go ahead and do the same configuration on R6. Interface tunnel 0. Paste. So we've got 4, interface tunnel 0, and paste. Do show run interface tunnel 0. Okay, now we see that we have a multicast mapping. Let's go back up to the hub and see what's going on. Show IP EIGRP neighbors. Notice my queue count here is still 1. Now, what I'm going to do is I'm going to statically map these to all 3 of these, because what's happening here is that this is an issue with the iOS that I'm currently running. I've run into this a couple of times on my demo, but it's important for you to know that you can do the dynamic method or you could do the static method. It's going to be based on what your instructions give you in the lab exam. So let's look at it from the point of view of creating these static mappings. So config T, interface tunnel 0, IP NHRP, map multicast 183.1, see 34.4, 36.6, and 35.5. Do show run interface tunnel 0. Now we're going to see, I've got both of these, but let's see what happens. Do show IP EIGRP neighbors. Now notice my Q counts have gone to 0. So now my peerings are up and my peerings are stable. From the point of view of the hub, do show IP route EIGRP. Okay, notice I'm learning prefixes. I got prefixes for 3, for 4, for 5, for 6. Let's take a look at this and see where these are being learned from. So notice 4, 5, and 6 are all being learned through my tunnel. So tunnel 0. So when I look at this, everything should be good to go, but the problem is if I go over to say like R4, show IP route EIGRP, what do I see? Well, I see 2 and I see 3, but I don't see 5 and I don't see 6. Do I have reachability to these? Can I ping the hub 222? Yes, I can. Can I ping myself 5.5.5 or 4.4.4? Yes. Can I ping 4.4.4? Sorry, wrong device. 5.5.5. I have no reachability to 5.5.5, nor am I going to have reachability to 6.6.6. I'm just going to go ahead and punch out of that and just say 6.6.6, just to illustrate that point. I don't have reachability. But this begs us to take a critical look at how EIGRP operates. First of all, DMVPN, we're learning about R4, 6, and 5 through one interface, tunnel 0. So now what we need to recognize here is that the EIGRP still uses split horizon. So what we need to do is we need to go in and actually disable split horizon in order to get reachability, because what's happening is we can reach the hub, but we can't reach the spokes. Because what's happening in this scenario is that we're not learning those prefixes because they're not being advertised to us as a direct result of EIGRP split horizons behavior. So let's take a look at that. So let's go over to R4, R2, config T, interface tunnel 0, no EIGRP, I always screw up this, EIGRP, IP, split horizon, EIGRP 100. I hate it when I screw up the syntax, but I do it almost invariably every time. Now, look at what happened. We resynchronized. Why? Because our split horizon behavior changed. Now, that means now if I go over to R6 and I look at my routing table, do show IP route, and I want to look for 5.5.5, I have it now. If I look for 4.4.4, I have it now. So now, if I ping 5.5.5, I have reachability. If I ping 4.4.4, I have reachability, and obviously I have reachability to 2.2.2.2. So just never lose sight of the fact that one of the reasons that we have DMVPN is so that Cisco can give us scenarios where we're going to be able to demonstrate that we have a firm grasp of the understanding behind how these protocols all operate in a non-broadcast multi-access environment. Now, the one thing I want to warn you about is that later on in our conversations, we're going to be talking about multicast behavior. Now, in the context of multicast behavior, DMVPN is not a non-broadcast multi-access environment. Because think about it, from the point of view of multicast, if I go in and say mode NBMA, what I'm doing is I'm actually going to be resolving it down to my layer 2 DLCs for frame relay. And there's no corresponding configuration like that in DMVPN, whether it's phase 1, phase 2, or phase 3. So what we've done now is we brought up the EIGRP. In the next video, what we'll do is we'll bring up OSPF and we'll talk about the basic configurations with it. And then what we're going to do is move to phase 2. I'll see you guys in that video. Bye-bye.